confirming with Scott. That is perfectly good.
Okay, we're done leak checking. There are no leaks. Should we continue loading to 4,500?
Let's do it. I think you can answer. Sorry.
No worries. We're at 4,500.
Okay. Ryan, if you want to, so the next step is going to have us slowly open the valve and then basically evacuate. So if we make sure that no one else is wondering besides you and Rock, Kyle, and Kyle should actually just head back to the rock cell right now. While you do that. Going to crack the valve very slowly, as little as possible, and then back away.
Do you want me to lock the gate between here and CLH first? Because it got opened again.
That's fine now.
Okay. So everyone's out. I'm now going to slowly open MVHE01.
You're not going to open it all the way, you're just going to crack it.
Got it. Alright, it's cracked. I'm now leaving the courtyard.
I will update you on it steady.
Okay.
500 PSI. PSI. At 1,000 PSI. Full 50 PSI. 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 1,000 PSI in helium. Point 250 in helium. Point 700 in helium. $500 on helium.
Before we move on to loading liquid methane.
We will wait until we are equilibrium at 4,500.
No, of course. I'm talking about after that.
I'll let you know the next step is I'm monitoring 4 things I want to know.
Sorry.
Helium is at 4,570 PSI. Helium is at 4,700 PSI. Helium is stable at 4725. Hang on, we're going to let it cool off a little bit as with an equilibrium with the surroundings. It was steady. We are at 4,700. We're gonna run from there. You're good to go out. You guys, first thing you do, check the door, please.
Check the door, it's almost empty.
Let's swap that door. I'm closing the solenoid transfer valve. You guys are good, sir. You might want to grab some people.
Any other valves for the LM2? Tell us exactly what valves that we should close, because right now I'm assuming no valves.
You're going to want to close, you shouldn't have to close anything at this point, just the liquid valves on the doer and the pressurization valve on the doer. You also want to close MBN209 on the pressurization line. Confirm, that is the liquid nitrogen doer, liquid valve, liquid nitrogen vent valves, and then you're going to want to close MBN209, the supply pressurization valve.
Okay. Those three valves are closed.
Now crack the hose loose and prevent any N2 gases built in.
Kyle's suggesting we close MVLN203 so we don't have liquid nitrogen flowing backwards through the filter.
I currently have the solenoid closed.
But the filter is before the solenoid.
Okay, then close MVLN203.
Okay, closing.
That wrench is ready to go. As soon as that valve's closed, you're going to have the flex line locked up.
Yeah, we have wrenches already.
Yep.
What was that?
I heard you say something on the radio. Want to double check.
No, somebody said we should have wrenches ready, and I said we already have them out here.
Perfect.
We just went back to get our PPE.
Your bus in front of about 50 people right now. Can you move to the left or right?
This is a quick audio update from Eli in the new streaming room. Expect potential lagging on the video for a second. We're messing around with the video streaming lines in-house.
James, we're good to move ahead.
Okay, can you confirm for me a couple things real quick? First, manual valves are reset, so MBN209 is on. the vent valve is open and depressurized the doer.
We have not opened anything yet. I'm going to open those right now.
Okay, so open the pressurization ones first, and then open the liquid valve, and then open MBLN203.
Okay, the valves on the doer are open. Silas?
Okay, so the doer valves are open. Open MBN209.
Isn't that the one on the doer?
MBN209 should be on the ground support panel. It'll be the pressurization for the doer.
You open MVL in 203?
If you open MBN209, go for it.
Yes.
Going to be venting the PVLN201. Just a heads up, it's at 175 psi. It'll just be a little loud. I don't want to see you guys.
Okay, thanks.
That valve is open. Let me know. I'm going to open up the transfer line. Am I good to open my solenoid transfer line?
Can you repeat that?
Are you ready for me to open the solenoid?
Yes.
Okay, we're on to aux transfer. And by transfer, I mean oxygen loading in preparation of the doer.
Yep.
Please verify that the manual liquid oxygen doer liquid valve MB-OXO1 is closed. Same thing for the doer vent valve, MB-OXO2. MB-OXO3, the liquid oxygen valve, manual liquid oxygen valve is closed.
It's closed.
Okay, verify the liquid oxygen doer pressure. Please repeat it back to me when you get it. I need a heads up on the viewer pressure, please.
30, didn't you hear?
I did not hear that.
Alright, well, it's 230, sorry.
Okay, open up the vent valve, bring it down to 50 psi, please. Viewer pressure. And Kyle, can we close off the manual valve on our globe and put it into 05. MBLN205. Can we please throttle that down a little bit more?
Can you repeat that?
Please throttle MBLN205 close a little more until we were reading we slow our descent rate because we're dropping pretty fast on that temperature.
1 second, I'm walking away from the venting. You're going to need to say that a third time.
Please throttle MBLN205.
Throttle MBLN205, aye?
We'll hold off on second. That was about good. Get this set, yeah, perfect. What we're doing.
Doer is now at 50 psi.
Okay, turn on the liquid oxygen doer pressure build circuit, and then verify the liquid oxygen vent valve. The OXO 3, which is my end, is open.
Repeat that.
Turn on the liquid oxygen doer pressure build circuit, and stand by for loading, getting ready to load chill and oxygen.
To do that, there's not a valve for just pressure build.
Deploying it back to the sky. Scott.
Do it again.
Chris is coming with Scott. We're gonna help you guys get that going. On the doer, what do you guys think? What's the value on that?
Lots or not?
LN2. LN2.
Yeah, it's still at full.
Dope. Quick look at the oxygen vent valve, verify it is open, verify the liquid oxygen run valve is closed, and then we'll get ready for transfer once Scott gets up there.
He's not.
Someone else said something on the radio. Could you repeat that?
He's not on the east. Confirm you want locked vent open.
That is my PV aux 03 open, not the aux doer.
Okay, we've opened it.
All right. What did you just open? MV aux 03?
Yeah.
Close MV aux 03, please.
The pressure build circuit on the lock door. We don't know how to operate it.
No, what did please just I saw you turn something. What did you just turn?
He told us open MV.
Oh, I said verify that PV aux 03 is open. Not open. Please close MV aux 03. We do not need it open. I don't think you're doing anything by doing that because it's not chilled in at all. We haven't opened the door, so it's fine.
MV aux 03.
I'll try and enunciate my M's and T's a little more.
Okay. Vent is open.
Cool. Verify the locks run is closed.
Is closed.
Cool beans. Whenever Scott gets out there and we find him, we're good to open the door. Is Roland behind you with the camera? See if he can help you guys.
Yeah, he is, but Scott just got here. is going to go back and discuss with you the use of the pressure build circuit on the locked door.
Okay, ready for him. At this point, let's open the manual liquid oxygen doer liquid valve, MD Ox01.
Okay, opening manual liquid oxygen doer valve. Valve is open. Did you get that?
Yes, I got that. Thank you. Let's open up manual liquid oxygen valve, MD Ox03. Can you also get me a read on the liquid nitrogen doer volume?
The volume is still reading full. What was the first valve name that you wanted open?
Now open M as in Mary, D Ox03.
Okay.
We're going to begin with our into methane conditioning part 2. We have completed 2.58. We are at steady state in our condenser. Just verifying that we're on where we are. Let's we have done this. We are at steady state with liquid nitrogen in the jacket. Please open manual gaseous methane isolation valve, MDFU01.
Valve is open.
Please open MDFU01. Sorry, open the methane cylinders.
Opening all of these cylinders.
Open all 3 methane cylinders. Q01 to 50 psi GC.
Oh,
Okay, we're at 50 psi.
Okay. If you guys want to back off, there's going to be a lot of venting gases, and we may pull the release valve as we did the first time we did this in February. So I'm going to be pulsing the gaseous methane isolation valve, DVQ05, and conditioning methane.
Okay, we have some people in the back of the courtyard. Do you want us to clear them out?
Oh, that's fine. I'm more worried about you guys getting vapor.
Okay.
Okay, pulsing.
We are under the device of Scott venting the second lock door just so it's ready in case we need to use it. Are we good to go check on it?
Yes.
Okay.
Can I have someone, Ryan or Kyle, open up the needle valve a little bit? Open it about a quarter of a turn. Sorry, the throttling needle valve on the condenser, that is.
Say it again?
please open the condenser needle valve MB-LN205, a quarter of a turn.
Okay, that's what we did.
Ladies and gentlemen, this is an audio update from Eli inside of the room for streaming. I have a checklist now. Now that we're getting closer, I will leave the radio on, of course, but I'm going to start talking you guys mainly through the steps as updating it over text. Well, it would just take too long. So we are getting very close to the firing process. This is where everything can start to go wrong, but it's also where everything can start to go right. We are finishing up condensing methane. We're going to begin to load oxygen and methane, pressurize both of them. There's lots of testing in between each of those steps, and it's going to be very, very exciting. So without further ado, I'm going to head back to the radio, listen very closely to what they're saying. You'll be able to follow what's going along. Every now and then, I will interject when we hit a new step. While we have a short break in radio communication, I can actually, well, we don't need the video back on. We've got a little bit of audio just for me, Eli, back in the control room here to answer a few questions we have in the comments. So we have asked, is the current configuration of your rocket your flight configuration? It seems like you have a lot of external ground support. We do have a lot of external ground support as we have to fuel our rocket. This will all be mounted on a trailer, of course, and it is mobile. Our methane, again, as you can see, what Chris said, is starting to condense. This will all be mobile, and it's all will be much more modular and able to be disconnected. In this case, we just assembled just enough of the rocket that we can hot fire, and no more. All the rest of the parts are back in our warehouse, about 500 yards from this building. Zeke says he's interested in the choice of LOX LCH4. The advantages, yes, as Tim said, it was one of the criteria for the competition. Basically, there's a $50,000 prize for getting the closest to 45,000 feet for a
go ahead and up the regulator pressure on, that is MRFU01 to 100 psi, please.
Right, so $50,000 to get close to 45,000 feet, and an extra $50,000 if you did it with personally get the closest to 45,000 feet with LOX methane. We're hoping to get both prizes, of course, because why not go for broke, you know?
At 62.
Say that again?
I currently read PTFU04 at 63 psi. Could you raise that another 30 or so?
Okay, you're going to have to read out because I'm reading at 100 right now.
Okay.
Okay, I'm slowly increasing now.
You're good to leave it here. I'm not seeing any increase.
So don't turn it anymore?
No, you're good. We'll hold here.
Okay.
What's methane supply at? Can you read the gauge?
Methane supply is at 1,600.
For those of you just joining us, a short update. We are prepping for fuel loading right now. Hot fire expected within hopefully the next 30 minutes, unless something goes very wrong. Currently, all systems are nominal.
We appear to have equalized our pressures across the system. I believe we have fully condensed our methane in the condenser.
The plumbing is insulated, but yes, you might see it start condensing on the outside.
We are loading up. So the regulator is going up to 100 psi. Can you go verify the gauge? See what your set pressure is on that gauge, please. MRFU01.
MRFU01.
Yes. What is the gauge to right now?
100 psi.
Let's leave it there. We're condensing. We have equalized pressures on both sides. We have methane in our condenser. I believe we are ready to move to preparations for fuel loading. So at this time, camera people, we would like to start all cameras. It's all GoPros.
Silas is requesting that the people outside in the courtyard start their cameras physically recording then their 4K data, including our slow motion cameras.
Confirmed.
Please verify that the ignition leads are connected to the igniter.
All right, we're beginning our prep for fuel loading stage. That's Silas asking to ensure that our igniter is in the proper system. Sorry, location.
Verified.
Are we going to close helium fill and proceed on? Okay, I'm going to say we're good. Let's close the manual helium fill valve. Hold off on that until we are all cameras are started. Once all cameras are started, we'll close the MVHE01. Just coming out to check those, so hold off on that for a second.
In a few moments here, Silas will request that everybody is cleared out of the courtyard, out of the test cells connecting to this courtyard. That we remove, as you can see Chris doing.
Actually, at this time, please do one last sweep for fog. All other personnel in the courtyard, just do a sweep for fog.
Speak of the devil. There it is. Requesting that all personnel essentially exit the front half of this building.
Can we for that last statement?
After this, the test cells will be sealed.
Can we re-verify the MVFU01 set pressure? I'm reading 140 psi on my system.
Oh, we got an error.
Maybe like 105. I think our gauge is just bad, and the resolution's also poor.
Okay, we'll just have to run with it.
Never mind, it's like 98. Well, you know what I mean.
Ah, yes, rocket science. You know what I mean. My favorite part.
Our thought has been completed. Ryan, you're the only one out there right now, correct?
No, there's Chris and Rohan working on a camera.
Okay.
For those of us just joining, we are about halfway through our prep for fuel loading stage. After this, we clear the courtyard, load aux, load methane, and get ready to fire.
A read on the Dewar, liquid LN2 Dewar pressure. It just has a needle that points to flow.
Okay.
Again, a short update for those joining us. We are halfway through our prep for fuel loading stage. In just a few minutes here, we should complete clearing of the courtyard, sealing of the test cells.
Target to change the test cell gate shut while you're waiting.
There's a request to change the test cell gate shut. Essentially, we're evacuating people from this courtyard and the nearest part of this building. And we'll all be backing off into the control room and rooms further back. All personnel will be cleared from other locations in Zucro laboratories and instructed to remain inside for the duration of the test. We have a program sequence, Daniel.
Both courtyard gates are now shut and locked.
Yes, sorry, my bad.
No worries.
Pressure is above 900. We are, nitrogen pressure is above 900. Helium is still breathing steady at 4678. The L8 is cleared. Close MDHE01. Clear the test cells. One of you each go through it. Overhead doors. Actually, before you close MDHE01, why don't you go turn on the hose and make sure we have water.
I was going to do that.
Verifying that we can get water.
He's on his way to the GT cell right now. Close, he has to go around.
Clear the ignition leads from the water line. Looks good.
All right, ladies and gentlemen who are just joining us again, we are finally getting right near to the end of our prep for fuel loading process. And as soon as Ryan clears out of the courtyard, we will actually begin the fuel loading process. liquid oxygen loads first. This will be the most likely to cause trouble, as pure oxygen in any non-clean environment can result in a catastrophic failure. Many of these pipes were too long to properly
Verify the ignition leads are not touching at all. There's no contact between them.
Okay, but I'm looking again now. Okay, we're ready to turn the water on. Let us know how it looks. Ignition leads are not touching.
The voices you hear are Silas,
Okay, you're good to start on water.
Ryan, one of our main propulsion engineers. He designed the injector. And Scott, the head here.
That's pretty good. Okay, let's turn water off. Ryan, close MV-HE01.
The water you see running is to prevent the
Water it off.
the metal
closed.
plate from entirely
Clear all
disappearing.
personnel from courtyard and test cells, data rooms, control room, and ops room. Shut overhead doors and test cells.
All right, we're sealing off the courtyard from the rest of the building and clearing all people.
Okay, can you give me those one or two at a time so I make sure I don't miss anything?
Okay, shut the test cell overhead doors on your way in. Both of you, GT cell and rocket cell.
You can see Chris updating in text. Those updates will be theoretically more live than my voice, as you guys have a 35 to 45 second delay. I'll ask him to stop updating.
Cell door is shut except for the crack.
I'll ask him to stop updating when we get near to fire, because I will leave the room as it is about 45 seconds delayed on your time, and I want to go witness it with my teammates in the other room, and I'll be back about a minute to talk to you guys about it after it is done. For now, though, I will continue to stay here while we begin the propellant loading process. Yes, Daniel, we theoretically do have enough propellant, but we'll just be up very late.
Door is shut.
Okay. Clear personnel back from the test cells, data room, control room, ops room.
Can you repeat that, Silas?
Clear. Make sure there's no stragglers in the rocket cell or GT cell. Chain all doors on your way back in.
Okay.
I'll just respond in text to this.
Each cell and rocket cell are swept in chains. Container sweep has been done, and those exits are changed.
Okay. Did you sweep behind the courtyard as well?
Whew. It's getting intense.
I'm ready to begin liquid oxygen loading. PV Ox 2. Everyone is back and accounted for? Ryan, where are you? Opening the transfer line. Pressure is at 37 degrees.
All right, just to fill the gaps in the silence, they are prepping the control room right now for the beginning stages of aux loading. Just a few minutes here. Estimated time to test fire. All right, well, I just got an update. There is no delay. We are currently waiting for the, I believe aux is flowing at 38 psi. And once it gets in there,
I'm monitoring stuff. You guys are good to open up the pressure button.
once it gets into the rocket, we have to wait for it to
Report
cool.
tank pressure changes if I see them.
So they've given me an estimate of anywhere from 10 to 30 minutes.
Open them and
That's all I can do. Yes, Daniel, we are going to chill. Non-rocket people, he's not talking about chill like sit back. He's talking about the actual tanks, the cryo system.
Okay, is it normal for the pressure build circuit to turn at 1/8 turn only? It should turn multiple turns.
Boiler
Okay,
up.
it's open and we're leaving. Okay.
Thank you, Tim. Boiler up, hammer down. Best school on earth. All right. While we wait for this fuel loading process to continue, because we have such a high amount of people on the stream now, most of them who haven't heard our spiel beforehand, I'm going to give you guys all a quick overview of what is going on, what's been done today and in the last few days. Hi, Cole. And a little bit of the specs on this rocket. So this is, we are part of Purdue Space Program out here in West Lafayette, Indiana, Purdue University. We're out here at Zucrow Laboratories. Zucrow Laboratories was built in 1948, right at the dawn of the space age, and has pretty much worked right alongside NASA from then until now. A lot of significant research came out of here to go into our space program. We are the largest academic propulsion lab in the country. We're home to about 160 grad students, and they work on world-leading research here. The team itself is 60 undergraduates and 4 graduate students representing a total of 5 different countries. It's a little bit, or it's very cool to us that we have the opportunity to allow international students here, as none of our projects are ITAR controlled, which is a true blessing both for them and for us. It allows us to pull from all parts of our school. So some stats on the rocket, specifically the wonderful engine we're testing today. Theoretically, this engine should produce 1,125 pounds force for 8.1 seconds. It has a chamber pressure of 550 psi, a theoretical ISP of 260. Again, we'll be determining most of these values and a lot of the other performance characteristics, including C-star efficiency, with the data we actually gathered today. The rocket itself is theoretically to weigh about 120 pounds. It's 6.5 inches in diameter and about 14 feet tall. The rocket engine itself is made from silica phenolic, which is an ablative wrapped in carbon fiber, uses a pentyl injection system, and we are fueled by liquid oxygen and liquid methane. We chose liquid oxygen and liquid methane just due to the competition requirements, as we get a larger cash prize if we win. Plus, we love accepting and taking on challenges here, and this was something Zucrow Labs hasn't done before. And it was a very exciting project. Our data will actually be valuable to other future projects. Rob, we are going to work on getting a notification at T-minus 5 minutes. William, it's going to be anywhere from 10 minutes to 30 minutes. It just depends on how fast our ox and methane loading happens and the chilling happens. We'll get the radio back on so you can hear the chatter from the ops room. While we wait, feel free to ask any other questions that you guys might have. Some of them will answer over voice, some of them will answer over text. We'll have to manufacture just the ablative layer, theoretically, and wrap it in carbon fiber, of course, but it will disconnect from the pentyl injector after a hot fire. Good question. Eric, I'm not sure the answer to that question. I can get that for you from the guys in the ops room if they've got any extra time right now, but they are a little bit busy. Jennifer, the methane gas is already condensed. We are simply waiting to load it. Ox loads first. How critical was Kevin Cohen to design on this rocket? Well, Kevin Cohen designed this rocket himself. Every piece. Truly irreplaceable. Kevin, if you're watching, we love you. We wish you were here. For those of you who don't know, Kevin is currently not in West Lafayette, Indiana, although he was a key member on this team. Helped design our DAC, among other things. There you go. So Matt Tanner answered DP is 20%. Matt Tanner is also not here right now, but watching the live stream along with many other members of our team who aren't able to be here at Zucro today. Matt Tanner helped design a significant amount of the propulsion system. Matt, you want to take that question from Brian? We use pressure transducers. Jennifer, I don't know that answer off the top of my head. I wasn't timing it. The last few minutes. By few minutes, I mean upwards of 20. All right, we don't seem to be getting any updates from the ops room. I'm going to leave here in a second and make sure that their radio system's working. That's correct, Cole. The gimbal was excluded for simplicity. We're not going high enough to really warrant a control system. In fact, the very next design the rocket we design will be based off this, and it will involve a gimbal. In fact, it's our most significant design challenge for the next rocket. All right, I'm going to go talk to the ops room for a second and see if they either have no updates or their radio's broken. Be back soon. All right, guys, a quick update from the control room. We're not getting the exact right responses we're looking for from the sensors on the rocket for the aux fuel loading. So they're discussing some ways to make sure that it goes smoother. We have to do it all remotely because we cannot send somebody out there due to the danger of liquid oxygen. We actually haven't started designing, Dinesh. That will all happen after this rocket is done. We we talk about it a lot, but we make a point here to focus on one project at a time. So we'll start designing the gambling system this summer if this project goes to plan, and then after that, and we kind of just go real hard on one project at a time. Well, Eric, assuming we do get a
Okay, we are approaching the setup test stand.
I'm closing the rocket oxygen vent valve.
Okay, we good to go all the way in?
You're good to go all the way in.
All right, we're going to troubleshoot the oxygen flow. Funny, Mark. Jennifer, we have a significant amount of data collection going on, both in forms of video and raw numerical data. I believe there's 12 separate thermocouples on this rocket, on this ground support apparatus and the rocket, along with pressure transducers.
Just to note, the LNC doer is at 3/4.
Among other
Launch
sensors.
doer is about 55 or 60 psi.
The cap was installed or no?
Yes, the cap is installed. We're waiting for this vent to finish before we go take it off.
Daniel, I'm not sure, but I believe part of that's part of our proprietary design for this competition.
Helping launch transfer.
Kind of our spooky secret that we figured out to save weight, as the valves are very heavy. Yeah, Dinesh, we'll definitely ping you. That'd be awesome.
30 psi, just unscrew the cap.
What was that?
I'm reading 30 psi in your vent. Be good to just crack that vent open and let the line volume blow out.
Kyle wants you to shut the LN2 vent.
LN2 vent shut.
Okay, the cap has been removed.
Okay, let me know when you're back for rocket stuff.
I'm just gonna give Rohan and Pratt another minute.
Cool, the burn will be 8.1 seconds, both for this test and for the real flight.
You could resume nitrogen vent.
We'll do when the pressure is high enough.
Commercial off-the-shelf components, Mark. By the way, guys, if you see updates from Christopher Nilsson, he is our project team lead. He is in the ops room right now. Oh, 8.2 seconds, Matt. Yes, of course. My document says 8.1. Thank you. All right. Currently, Ryan is vacating the premises, and we're going to try again, loading up the aux. Yes, Cole, very short burn time, very high acceleration.
Give Brett and Rohan positive reinforcement and tell them to move faster.
Okay, we're exiting the courtyard.
Okay, let me know when you're clear and doors are shut. Replays all change on the way in.
Yeah, Matt, you're definitely wrong. I'm definitely right. Matt, you're actually in propulsion. You're probably closer to right. Although I do do have a written document here, but we'll see. I guess truly today we'll get the real burn time.
Give us a minute, doors slow.
Cole, we can't throttle this rocket.
Guys clear? Door shut?
Yes.
Okay, resuming aux transfer.
All right, I'm going to turn the radio up. Let you guys listen to Silas. Although during aux transfer, he may be relatively quiet. Let's just hope it works. Silica phenolic, Z.
Oxygen appears to be transferring. Line is starting chilling at the top. We're starting to get a temperature drop. Aux tank is confirmed sign of chilling in.
All right, we're on the second to last step of liquid oxygen loading. We're looking for a oxygen tank reading below negative 290 Fahrenheit. Cole, the phenolic nozzle is manufactured off-site by a contractor. Same answer to you, Dallas. After the aux finishes loading, we're going to do one final sweep of the exterior areas around the high pressure lab here. Ensure no one is working unaware of the pending test, and to get everybody inside. Very spicy. Extra spice. 7 spice, at least. Cole, we discussed the igniter earlier, but for those of you that didn't hear what we've done, we initially wanted a fancier igniter system, like a small propane torch or something of the sort inside of the chamber, but it proved that we didn't have enough time. So quite literally about 48 hours ago, I started initial design, build, and testing of a makeshift MacGyver igniter, and about 24 hours ago, we finished the design. It's, as Samuel just said, it's essentially a hobby motor, not Estes brand, but similar. We cut chunks out of it, drilled holes in it, mounted it on a stick, put in a little bit of black powder, and a hobby igniter initiator. The initiator ignites the black powder ignites the solid fuel. Solid fuel burns from an average of 6 to 9 seconds with a 1.5 second start delay maximum. So we program that into our timing sequence, and then it'll just burn. Yep, very true, Cole. We essentially have a mini Soyuz match. Ben, we don't have a clear estimate. We're currently loading liquid oxygen, so theoretically we could finish fire, or we could get ready and fire within a few minutes, few minutes. But if we continue to have slight errors like we just did, we'll continue to have delays. It's kind of up in the air right now. Every few minutes I'll run over the ops room and get you guys a clearer update. There's a quick update from Chris. You guys will see it before you actually hear me. Lock chill 90%. Brandon, the cap was still on one of the aux lines, so we started the filling process and the tanks were not filling. Darn right, Hubert. I made one of them myself. Although, can't thank me for those fins. Most of the grunt work was done by Emily Endicott, our systems engineer, and Robert Groom, our manufacturing lead, who have put, and among other people, including Jacob and Ben and myself, have put a absolutely ridiculous, mind-numbing amount of hours in at Bechtel Innovation Design Center, which is the student machine shop here at Purdue University. Most of the parts on this rocket are handmade by us here in-house by the undergrads and graduate students. No, we're not competing in IREC. We're competing in the FARS Mars competition in May. We also have another team competing in Spaceport Cup, but that's where it ends for rocket teams for us this year. All right, with that update from Chris, it should be just a few more minutes here until we reach full oxygen chilling, and we'll move on to the next step and begin liquid methane loading. Oh, that's a correction from Ben. I guess we will have a team in IREC. That was misspoken by me. Ben can probably tell you more about that. He's our technical director for Purdue SEDS. All right, I guess I misspoke when I said the Spaceport Cup. That is the IREC team. So there you guys go.
For those in the conference room and on stream, we're going to be swapping an LN2, or we're going to be swapping our head 2 bottle, and then we're going to be preparing for last call.
All right, that was an update from Silas. If you guys did not hear or could not understand, we're about to swap our LN2 bottle. That's what you can see. Ryan.
All right, are we good to close MVN204? Observing, go for it.
As you can see, Ryan and Kyle doing right now.
Have the bottle next to you. Anyone?
Sorry about that. Scott was talking to us. We're getting the bottle.
Okay, do you hear me?
We are going to reopen MVN204 until we have the bottle ready to minimize our downtime.
Thank you.
Have someone bring Scott the courtyard key.
Nitrogen, hang on.
At least 7 lumens, Jeremy. Kidding. In actuality, we have no idea. It's going to be bright, though. It'll probably blow out this camera before it adjusts fast enough, so you guys might not get a perfect view, but we will upload a better video after the fact. Oomph. How much oomph? Specifically predicted 1,124, 25-pound force. LBF. The Swimmer 36, I'm not sure we have a technical term, it's just our ground support equipment. But yes, we did make it all ourselves. More specifically,
We are now shutting MV and 204.
more specifically, Kyle
Monitoring.
put a significant amount of time into it. You can see him on the right there messing with some of the
Are we good to do it?
on the ground support system.
Go for it. I'm just monitoring. I'll keep you guys
Yes,
posted.
Eric, other universities have flown them, but they're becoming significantly more popular as SpaceX has slowly popularized space.
Closing cylinders, and then we're going to open MV and 208.
Go for it.
Oh, definitely not, Matty. It was at least 7 oops. Come on, give us some credit. This is Zucro Labs we're talking about here. Brandon, the condenser has actually been working great.
We are not going to be reopening the empty cylinder. We are good to open nitrogen.
Support.
All right, they're almost finished swapping out our nitrogen. When they're done with that, we'll be able to continue the loading process.
Okay, reopening MV and 204. Okay, we are going to equalize between the two cylinders. We changed our mind.
Okay.
Yes, we're using thermocouples, pressure transducers, and the load cell.
Oxygen tank is at negative 125 F. Currently 10 pounds of 24 pounds loaded.
LM doer is at 2/3 full.
Sorry, the liquid nitrogen is at 2/3 full?
That is correct.
How about liquid oxygen?
It's got a lot in it.
A lot works for me. Okay.
It's not really anything to read. Feels pretty heavy.
Well, we are still cooling at a steady rate. We're at negative 135 on the temperatures. I'm going to start LM2 transfer back through on the.
Well, sticky cover. We do. That's why we have them.
Okay, we're leaving the courtyard.
Okay, let me know when you have closed the door and you guys are safe.
Oh, excuse you, Matt. My hair is definitely the curliest.
Negative 160F on oxygen. £15 of oxygen in the rocket.
Eli, Stitch and ETA on methane loading. We're not sure. You might have heard recently we updated 15 pounds of oxygen inside the rocket right now. And we're hoping we can get started loading methane soon. You'll hear it pretty clear over the radio. Honestly, though, I can't give you a direct ETA. We can hope within 10 minutes. All right, short update from the control room. Looks like LOX loading is over 2/3 complete. It is going a little bit slower than predicted. It's currently 1:57 a.m. Eastern Standard Time. Nathan does have his priorities in order. That is very true. I think along with the rest of us. Gonna be a lot of homework being done tomorrow morning.
18.5 pounds of box loaded, negative 200 on temperature.
All right, you guys heard that update? It's 18.5 pounds loaded, negative 200 on temperature. We're searching for a negative 290. Grant, yes, we do. We have an aerospace major here at Purdue. A significant portion of this team are aero majors. Grant, that's largely been changing this year. We kind of had to prove ourselves a little bit. Initially, we just had support from Scott out here at Zucro, but it's as we slowly prove our worth, you could say. We've slowly been building up our rep among the university and getting more support from professors.
21 pounds of oxygen loaded, negative 214 on vent, beginning to recondense methane.
Anyway, lots of professors now are slowly hearing word of who we are, getting more excited. Machine shops, as far as that goes, we're a little special here at Purdue. We have Bechtel Innovation Design Center, and we have the ASL, Aerospace Science Laboratory, which we can use for a lot of manufacturing. But yes, as Robert just said, we really don't have that much connection. Zucro really is our little bastion out here, and without them, we would be nowhere. They provide us our warehouse. They provide us a significant amount of our equipment. They provide us their time. They provide us their minds. They're kind of half PSP. We do love them. Well, Steven, I want you to imagine me, a 5'8" kid, filling those tanks with Simple Green and hot water and shaking them physically. And then filling those tanks with IPA and shaking them again. That's it. It was a lot of fun, actually. Good workout. Traded off Chris, myself, and Emily. Oh, excuse you, Matt. Excuse you. At least 5'8.5". Thank you. IPA, excuse me, isopropyl, oh, I can't even say it. It's too late. Yes, isopropyl alcohol. Thank you. Oh, we did use the plastic water pump, but we also shook it, just for good measure.
We just dropped on Hawks. Tank is looking like it's set. We're at negative 250. Hawks tank is confirmed filled in. We have 24 pounds in the tank. We're going to begin procedures of pre-test. So,
All right, folks.
safety officer, please warn non-test personnel of impending tests. Sweep exterior courtyards made by the containers. Make sure no one is wandered outside.
We're moving on to the pre-test phase after locks
We have
loading.
verified our timing sequence. We have verified our red line sequence. No, we have not. We will do that when Scott gets back in.
They're currently in the pre-test
Timing is
phase.
set.
Sweeping the courtyard, then they'll verify timing
No
and red
data
line.
motion being done tonight. Too late. No file names. No DOD.
After this process, they will start the liquid methane loading.
Verifying that liquid oxygen fill valve is open. PV oxo 3 is open. PV oxo 2 and PV oxo 3 are open. PVFU 03 is open. When safety officer gets back, I'll open PVFU 02 to begin fuel transfer.
Fuel transfer is getting ready to begin.
Opening methane fill valve, PVFU 02 to begin transfer. Opening now. Reading pressure in fuel tank is 83 on the inlet.
All right, ladies and gentlemen, I'm going to leave you guys here to listen to this and join my
18.9
teammates in the
on
next room. Silas will keep you guys updated on the radio.
This is reading 255, 250. Monitoring now. Should we do pre-test procedures? temperature on methane has crashed. Pressure is transferred. We are going to confirm that we are full. Please close methane fill valve. Clean methane fill valve. Methane fill transfer is finished. Okay, non-personnel have been warned. Test operator, please don't open the water line and the thrust plate in the GT cell. On your way back in, please verify that chains and barricades are still up. All personnel are out of the build-up area. Cockpit pressures are reading as hit. $29 pounds of propellant loaded in the rocket. We're going to resume PVFU-O2 transfer. We're warming up our methane. Section 4, propellant pressurization for test. Okay, closing PVFU-O2. Closing liquid methane vent valve, PVFU-O3. Closing gaseous methane supply valve, PVFU-O5. Closing PV-OX-O2, the transfer line. Closing PV-OX-O3, the vent line. It's time to say goodbye to the rocket guys. Okay, going through auto sequence. Verifying timing. Timing comes up spark igniter on at 8. All other valves commanded open at 10. Run valves commanded open at 10. Fill and vent lines off. Oxygen comes on at the very end. Fuel abort state is verified. Timing is verified. Red lines do not exist anymore. Personnel accounted for. Anyone missing? Last call. Pressure is at 4686. IP cameras are up. Start IP camera recording. Opening PVHE-01. Pressurizing rocket. at 970. No problem on PT officer 2, not rising. Cycling helium valve. Venting methane. Stroke. We're not seeing a rise in our tank pressure. Venting oxygen. Take fuel tank. we have vented off propellants. We are at about half our propellant mass and that's still in the rocket. We are going to proceed with dumping our propellants in order to save the vent. We're going to start with dumping oxygen. Beginning dump, opening ox run valve.
All right, guys, it's Eli back here again. Thank you guys all so much for tuning in tonight. We had a plumbing issue. We're busy troubleshooting what the cause is. So as you can see, we're venting all of the fuel and oxygen in the tanks one by one. So we might be out here late tonight. We might not. We might fire tomorrow. We might not. I think we're going to try to get this fixed again tonight, but as far as this stream goes, it wouldn't be, I guess, kind of us to keep you guys waiting and keep you guys hoping. So we are indeed dumping. It may be a while before we fix find and fix the problem. Of course, the video will all be recorded, and we will upload the actual fire once it happens. We are just not sure of the timeline on that right now. The only thing they could give me was some sort of plumbing issue. So we are going to shut down the stream here. Thank you guys so much for tuning in. Thank you for your questions. Kind of sucks. We're gonna get some pots of coffee on, and we're gonna try to fix our problems. But that's it for tonight, guys. So thank you guys all so much. And we will be sure to update you guys if we have another live stream. But for sure, we will at least post the video on all forms of social media. And of course, we'll be posting the video on Reddit, among other places. So on the chance that we do actually fire tonight, we will re-up this live stream and post it places, but realistically, it may not happen, and I guess we can't expect you guys to stay up. So thank you guys all for your well wishes, and we will see you soon.